Welcome to our presentation on geodatabase basics. During this presentation, we'll talk about ESRI's geodatabase format, introduce you to some of the basics concerning the format, and hopefully show you how you can utilize this in your shop and gain a lot of benefit from it. My name is Trip Corbin. I'm CEO of EGIS Associates. EGIS is focused on providing cost-efficient and effective geospatial solutions that meet the growing needs of the public and private sector. Our mission is to help you consume the power of place using current technology standards, such as the geodatabase and applied spatial intelligence. I've been with the company since 2010. I'm a GIS certified professional, a certified floodplain manager, an ESRI certified trainer, as well as a Microsoft certified professional. So who is using the geodatabase now as their primary GIS storage format? I know there's a lot of y'all that are still out there using shapefiles or maybe even coverages, possibly AutoCAD DWG files or MicroStation DGN files. So why do you want to switch to the geodatabase? What are some of the advantages of it? Well, those are the things that we'll be covering here in this presentation as we move forward. So our agenda is this. We're going to talk about what the geodatabase is, some of the basics about it, the things we can store in it. And then we'll get into the various types of geodatabase because it comes in multiple flavors, if you will, and then the advantages to using the geodatabase. So what is the geodatabase? How is it different from shapefiles or coverages or CAD files? What's the big reason we want to switch to it? So that's what we'll talk about next. The geodatabase is ESRI's new standard data storage format. It's for ArcGIS, that's ArcGIS Desktop and Server. It replaces the coverages and shapefiles that we've used with old versions of Esri software, such as ArcView GIS, old ArcInfo Workstation. But it allows us to have a single container in which we can store our vector data, our raster data, our standalone tables, our address locators, our models. So all kinds of things that we use in GIS we can stick into this single container so we know where it's at. There's no more trying to hunt and peck and find where things have been stored at. It reduces data redundancy because, again, we have the single container. It's a very scalable format. We can start with a single user geodatabase and migrate that up into multi-users and multi-editors as our enterprise grows. It also allows us to validate our data. The power of GIS is its ability to perform analysis based on attributes and spatial relationships. But that analysis is only as good as the data behind it. So within the geodatabase, we have tools that allow us to validate the data, both the spatial and the attribute data, to make sure that it's correct. So that when we perform our analysis, we know the results that we get are also correct. The old saying, garbage in, garbage out applies. Well, if you don't know where your garbage is, you don't know if you're getting garbage out. And those validation rules that we can apply with a geodatabase ensures that we're not getting garbage out. So what kind of things can we store inside of the geodatabase? Well, there's a lot of different things we can store. Here we have an example of a geodatabase that was created for Pike County. In it we can see that we have a combination of things being stored. We have our feature classes. And a feature class is a collection of features that share a common geometry, that point, line, and polygon that most of us are familiar with, a common attribute table, and then a common spatial reference or coordinate system. So we can see here in our geodatabase that we can organize our feature classes as either standalone, meaning they're outside of a feature data set, or we can group them inside feature data sets that even allow for more functionality. And we can see that we can store multiple feature classes inside of this geodatabase. So we have points, we have lines, we have polygons, we have annotation feature classes, all being stored inside of this one container. So there's no, well, where's this shapefile? Where is that shapefile? What workspace is this coverage in? It's all stored in this nice, neat very organized container. We can also see in here that we have raster data stored. You can see down here at the bottom where it says courthouse. So that is a picture of the courthouse for Pike County that we've stored in. We've also got our aerials, you can see, located at the top of that directory tree. In here we see some other things. We see a standalone table being stored, the RC_RD names table, so we can store tables within here as well as our spatial data. You can also see at the top where it says Pike_addresses, that is our address locator, what we use for geocoding addresses against our spatial data. So we can store address locators in here. At the bottom you see a toolbox, tax_assessors, with a model in it to run for sales analysis. So we can actually, in this geodatabase, not only are we storing our spatial and tabular data and our raster data, we're actually storing some of the tools we use to perform analysis on it. So the geodatabase gives us this very flexible storage model to really put any kind of thing we use in a GIS, from a data perspective, from an analysis perspective, all into this one location that we can then easily manage and control levels of access through. In addition to those things that we talked about, we've got these things called relationship classes. So within the geodatabase, we can relate or tie or link, if you will, multiple feature classes together. So you can see parcel_address. So we've linked our address feature class, that point feature class you see under the property feature data set, with our parcel polygons. So we've tied those two together. So if I make an update to one, it can have an effect on the other. Another good example we'll see with this is something called feature linked annotation, so that we can create a relationship class between a feature, say it's a road, and an annotation feature class, maybe it's the road name, so that if I change the name of the road in the attribute table for the roads, it updates the annotation. If I delete that road, it can also delete the annotation associated with it. You can see in here I've got something called a topology, the parcel topology. That's part of that spatial validation that I was telling you about. So I can go in and create a topology in the geodatabase that says, okay, take these feature classes and apply this set of rules to them. So it might be that parcel polygons cannot overlap, or they must not have gaps, or each parcel polygon must be bounded by a feature in the parcel potential edges feature class. So I can apply these rules to my data through a topology, so I ensure that that data is clean. And once I apply those rules and validate against them, then I know where, if any, errors exist, which, if I'm doing analysis, is very important. Now I know how correct my analysis is going to be. So that ability is a very powerful tool that we don't get when we use shape files or coverages or AutoCAD drawings to store data. This is something we can only do inside of the geodatabase. So what types of geodatabase are there? I mentioned before there are different kinds of geodatabase. It comes in different flavors, if you will. So let's talk about the different types. Well, there are three basic types of geodatabase. There's the personal, which is built on Microsoft Access. There's a file geodatabase, which is relatively new compared to the others. They came out in ArcGIS 9.2. And then there's the SDE geodatabase, and it comes in a couple of different flavors itself. We have Workgroup and Enterprise, and recently they've added the personal SDE geodatabase. Okay. All of these can store spatial and attribute data in an RDBMS. It can store all the other things that we've talked about within these in some form or fashion. So let's look at the specifics of these three types. Okay, the first off is the personal geodatabase. This is one of the oldest types of geodatabase. When ArcGIS was first released, this is one of the options you had available to you. It was built on Microsoft Access, and obviously a lot of folks are familiar with it. That's why they chose it. But because it is built on Microsoft Access, it does have all the limits that Microsoft Access has. So, your database, your geodatabase can't be larger than 2 gigabytes. Once it hits about 500 megabytes, you start to see performance degrade with it, and degrade very quickly. Okay. Also, you can only have one editor at a time. The minute someone starts editing with a geodatabase, and it's in a personal geodatabase, it locks that geodatabase so no one else can perform any edits. So it's a single editor. It does allow for multiple users for viewing purposes. So you can have 10 people accessing data out of a personal geodatabase if they're just creating maps and visualizing the data, but only one person can be editing it at a time. The next type is the file geodatabase, and this is really an Esri proprietary format. It's kind of, think, if you're familiar with the old coverage model, think of the coverage model on steroids. It's the next evolution of that. So they actually have taken that idea of individual files and turned it into a proprietary relational database. Okay. It does have some limitations on it in that you can only store 1 terabyte per featured data set. So you can keep adding feature data sets, and that'll increase your storage capability. But you have to be careful in your design because you don't want to end up with too many of those so that it becomes unwieldy to manage. You can also have 1 editor per feature data set. So the file geodatabase will allow for multiple editors. However, you have to be, again, careful with your design because most map documents, MXD files, are going to pull layers from multiple feature classes within multiple feature data sets. So if your map is pulling data from your base map feature data set, as well as your water system feature data set, maybe your planning feature data set, okay? All of those data sets that get referenced when you start editing are going to get locked. So if you want to allow for multi-user editing within a file geodatabase, you've got to really think through your design of not only your geodatabase, but of your map documents so that you don't get overlapping use of the feature classes. Okay. Now, the file geodatabase, like the personal geodatabase, can be edited with all versions of ArcGIS Desktop. So all your licensing levels, whether it's ArcView, ArcEditor, or ArcInfo, or is the new nomenclature is going to be with 10.1, ArcGIS Desktop Basic, Standard, and Advanced. Okay.